Welcome back to James's Physics 101. Today we are exploring the universe's most unbreakable rule of motion, momentum. Think of a heavy train moving slowly versus a tiny bullet flying fast. Both are incredibly hard to stop. Why? Because both carry a massive amount of momentum. Let's break down the secret behind this cosmic force. In simple terms, momentum is mass in motion. It measures how difficult it is to stop any moving object. Mathematically, momentum is mass multiplied by velocity, represented as P equals mv. Its unit is kilogram meters per second. Since velocity has direction, momentum is also a vector. It points in the exact direction the object is traveling. Now, here is the big law. In a closed system, the total momentum remains completely constant over time. No matter what happens inside that system, momentum cannot be created or destroyed. It can only be transferred. This is most obvious during collisions, which physicists classify into two main categories, elastic and inelastic. In a perfectly elastic collision, objects bounce off each other without losing any of their collective kinetic energy. Think of billiard balls. When they strike, they bounce apart instantly, transferring almost all energy cleanly between them. The total momentum and kinetic energy before they hit perfectly equals the total momentum and energy afterward. In an inelastic collision, however, the colliding objects deform, generate heat, and often stick together. While total momentum is still conserved, kinetic energy is lost, transforming into heat, sound, or structural damage. A car crash is a classic example. The vehicles crumple, locking together as they slide to a stop. To visualize these laws simultaneously, let's look at a device named after me, the iconic Newton's Cradle. When you lift and release one steel ball, it transfers momentum through the others, launching just one ball. Why doesn't one ball stop and launch two balls at half the speed? Because kinetic energy would be lost. To satisfy both conservation laws at once, the cradle has to launch exactly the same number of balls. This conservation budget is also how we travel through the vacuum of space, using the physics of rockets. By expelling gas backwards at high speeds, the rocket gains an equal and opposite forward momentum. From subatomic particles colliding in accelerators to massive galaxies merging, momentum is the ultimate cosmic accounting system. No matter how complex the collision, the total momentum of the universe is always perfectly preserved. If you found this lesson helpful, please subscribe to James's Physics 101 and leave a comment below. Next time, we trade forces for funds as we explore work and energy, the universe's ultimate currency.